Hello, everyone. Before we start modeling, let me explain something important. CAD is not just about drawing shapes. The main purpose of CAD is to reduce errors between an idea and the final product. It allows engineers to convert a concept into something that can actually be manufactured. In this channel, I am not going to teach only Siemens NX commands. NX is just a tool. Most people can learn the basic operations in 2 or 3 months. What I want to teach is engineering thinking and design concepts. Now let's begin. First, enable the infinite cursor, also called the crosshair. This helps us clearly see horizontal and vertical alignment while sketching. Go to Enable Crosshair. Create a new part. Go to File, Arrow, New, Arrow, Part. Now let's look at the interface. This is the part Navigator, and this is the assembly Navigator. You can double click and drag these windows to place them anywhere on the screen. Many engineers prefer to keep the part Navigator and assembly Navigator separated because it improves workflow. For simple single part modeling, the difference is small. But when working with master skeleton modeling, separating them becomes very useful. I will explain master skeleton design methodology in a later video. Now, let's look at the part Navigator. All the features created in the model appear in this tree. The current feature column shows the structure of the model and how it was built step by step. If we want to modify the design later, we can simply activate a feature and edit it. Next is the up-to-date column. A check mark means the feature is updated correctly. If you see a cross mark, it means the feature has failed and needs to be fixed. Now let's move to the Assembly Navigator. In this tab, we mainly use 3 things: position, reference, set, count. The position column shows whether the component is fully constrained. A fully constrained component will not move randomly in the workspace. The count column shows how many components are present in the assembly. The reference set controls which geometry is visible in the assembly. I will explain this feature in detail in a future video. Now let's talk about the modeling workflow. Usually we follow this sequence when creating a model: datum to sketch to extrude or revolve to surface to draft to fillet to unite or subtract. You may ask why we follow this order. Sketch and extrude are already familiar to most designers. Draft is important for manufacturing. It allows the product to be removed easily from the die during molding or casting. Without draft angles, the die may damage the product. Fillets are also important. They help material flow smoothly inside the mold and reduce stress concentration. Now select a plane and enter sketch mode. Let's create a simple demonstration model. There is an important rule in CAD. A sketch must always be fully constrained. If a sketch is not constrained, it may move accidentally. This can create problems when modifying the model later. To constrain the sketch, apply horizontal and vertical dimensions relative to the default reference axis. If you want faster dimensioning, you can enable rapid dimension from the customization options. For example, when using the rectangle tool, if you create the rectangle from the center, NX automatically recognizes the center alignment. You only need to define the dimensions relative to the horizontal and vertical axis. To check whether the sketch is fully constrained, look at the status indicator at the bottom of the screen. When the sketch is fully constrained, the lines will turn green. Now, let me show a few commonly used sketch tools: trim, corner, extend. When you create a new line, you may notice it appears brown. This means the sketch element is not fully constrained. First, the trim tool, as the name suggests, removes the unwanted portion of a line. The extend tool requires a boundary to stop the extension. That is why I created a vertical line. Once the sketch is complete, click Finish Sketch. Now we will create the 3D geometry using extrude. When you activate the extrude command, two panels appear. One panel controls the extrusion parameters. The other panel controls the selection of sketch regions. I will explain these options in more detail in another video. For now, we will simply create the extrusion. After extrusion, the next step is draft. Draft angles should be defined based on the manufacturing process. For this demonstration, we will simply apply a basic draft. Next, we add fillets. NX has a useful feature where selecting one edge can automatically detect similar edges. This allows you to apply fillets quickly. Now, we can review how the part was created by looking at the current feature list. Next, we will remove material from the part. First, let's look Look at the shell feature. The shell command removes internal material and creates a hollow part with a defined wall thickness. Now we will try the trim body operation. For this, we need another separate feature or body. Here you can see that the last feature is not added or subtracted from the previous feature. It simply exists as another body in the workspace. Now we can use it to trim the main body. As you can see, the body is trimmed based on the selected geometry. This is the basic workflow for creating models in In the upcoming videos, we will create more complex models and also learn about assembly design. If there is a specific topic you want to learn, please write it in the comments. Next, we will remove material from the part. First, let's look at the shell feature. The shell command removes internal material and creates a hollow part with a defined wall thickness. Now we will try the trim body operation. For this, we need another separate feature or body. Here you can see that the last feature is not added or subtracted from the previous feature. It simply exists as another body in the workspace. Now we can use it to trim the main body. As you can see, the body is trimmed based on the selected geometry. This is the basic workflow for creating models in Siemens NX. In the upcoming videos, we will create more complex models and also learn about assembly design. If there is a specific topic you want to learn, please write it in the comments.